Hello everyone, welcome to JCE Connect. This is Computer Graphics Lab, and today we are going to start with our first experiment, that is to implement Bresenham's line drawing algorithm for all types of slopes. So before we move on to our source code, let us understand the algorithm behind the Bresenham's line drawing. So the first step in the algorithm is to input the two endpoints. Like any line, we need to have two endpoints of the line to draw the line, right? So we are going to take the input, the two line inputs endpoints, and to store the left endpoint in the x0 comma y0. So what we are going to do is we are going to take two inputs as two endpoints of the line, and we are going to store the left endpoint in the x0 comma y0. Now the second step is to load that x0 comma y0, which is the left endpoint, into the frame buffer, right? That is to plot the first point. So if there is a line, let's say this is a line, so leftmost point, that is this point, is x0 comma y0, and we are going to load that point x0 comma y0 into the buffer, frame buffer, as our first point, and this will be our point, let's say x1 comma y1. Okay, so the third step is to calculate the constant delta x comma delta y and 2 delta y, and also 2 delta y minus 2 delta x, that is the difference between the delta y and delta x, and then to obtain the starting value of the decision parameter, that as p naught value, that is the decision parameter p naught, which is the difference between the delta x and delta y, that is 2 delta y minus 2 delta x. Okay, so moving on, in the fourth step we have to for each x of k along the line with starting k is from 0, we have to perform few tests. What is that test? That is the condition, that is if p naught is less than 0, the next point to plot is x of k plus 1 comma y of k, the coordinates, and p of k plus 1 is equal to p of k plus 2 delta y, that is the next point that is we are going to plot. So if p naught is not less than 0, that is otherwise, the next point is to the next point to plot is the x of k plus 1 comma y of k plus 1, and p of k plus 1 is equal to p of k plus 2 delta y minus 2 delta x, right? So once we have these two tests performed, the next step is to repeat the steps for delta x times. So whatever that value of delta x would be, we are going to repeat it. So that is the algorithm for the uh, Bresenham's line drawing. So let us understand this with an example before we move on to the code. This is the line drawing algorithm with Cartesian equation y is equal to mx plus c, as you all know, where m is the slope and y is the intercept. Okay, and we have this coordinates, let's say x1 comma y1 is this point and x2 comma y2 is this point. Okay, and this is the formula for the slope. This is the basic, right? So here is an example to draw a line to the coordinate, let's say 20 comma 10 to 30 comma 18. So our x0 comma y0 becomes 20 comma 10, and our x1 comma y1 becomes 30 comma 18. So this is the line. Okay, so delta x is nothing but the dx. Dx here is the delta x, with the value of delta x is the 10 here, right? And value of delta y is 8, right? So initial decision, that is d naught, is equal to 2 of delta y minus delta x, that is p naught, what we have seen in the algorithm, right? So here in this example, the difference becomes 6, right? And also 2 dy is equal to 16 because dy is 8, right? So 2 dy is equal to 16, and 2 into dy minus dx, that is 2 into 8 minus dx, that is 10, gives you minus 4. 2 times of 8 minus 10, that is 2 into minus 2, which becomes minus 4. So that is our 2 dy. Sorry, 2 into dy minus dx. Now here is the table how the iterations takes place, right? We have to continuously repeat the same step to find the values, so that we plot a line ultimately. Fine. So let us understand now with the code how it can we implement this in the code. So now let us see the program for Bresenham's line drawing. First, include the header files, that is gl/gl.h, gl/glut.h, and as usual #include stdio.h for standard input output, and the above two, these two are for the line glut. Then initialize x1, y1 and x2, y2, that is our endpoints which have to be specified to draw line. X1 and y2 will be the first endpoint, that is leftmost, and x2, y2 will be the second endpoint. Let us see the main function, that is int argc and character argv. Argc is nothing but the argument counter, and argb is the vector that holds the number of sequence of arrays. So inside main we have printf and scanf function, which will take the input x1, y1, x2, y2 with ampersand argc and argv. Ampersand argc is the address for the argument counter, and argv is nothing but the array itself. Then we need to set the display mode. So we have glut in a display mode, glut underscore single, that is the single buffer. So in this program we need to just draw a line. So glut underscore single is enough. If we have many animations in the program, then we need to initialize double buffer, so it will be glut underscore double. Then we have glut underscore RGB, that is for the setting up the color for the display. Then we have glut init windows size, I have given as 500, and glut init windows position, which is 0, 0. Then we have glut create window, Bresenham's line drawing, which will be displayed on the left corner of your output. Then we have the callback function to call back the function, that is myInit, and glut display function. Let's see one by one. So first we have myInit function. We have GL clear with GL color underscore buffer underscore bit, which clears the background, which takes the parameter bitwise. So GL underscore color underscore buffer underscore bit is a constant, which says that the buffer currently enables. Then we have GL color clear color, which will clear the background. The background color which we have specified is black, which is this code 0, 0, 0, 1. Then we have GL matrix mode with GL underscore projection, which will define the property of the camera. Then we have GLU ortho 2D with 0, 500 and 0, 500 as the parameter, which is the projection. This is for the projection of the image. And here why we need to specify is we need the output within the range. So we have specified 0, 500 and 0, 500. So next, let's see the display function, that is void my display. Here draw line is the callback function with x1 and x2 and y1 and y2 are the parameters, which are the endpoints. Then we have let's see, first of all, let's see what is this draw line function. Inside this draw line function, it is nothing but the algorithm which we have already seen. So we have to first initialize dx, dy and ine. Dx is nothing but the delta x and delta y, and e is nothing but the p naught, which we have seen in the algorithm. Then we initialize the increment x, increment y, increment I, and increment 2. Increment 1 and increment 2, sorry. Then increment, in the algorithm we have learned that we have to calculate the delta x and delta y. So delta x, which is dx, is equal to x2 minus x1, and y2 dy will be y2 minus y1. So while drawing the line can be any of the 4 quadrant. So if it is in the third quadrant, we would be having some negative values of x and y. So this condition is necessary. That is, if dx is less than 0 and dy is less than 0, then dx would be minus dx and dy would be minus dy. So the increment x is equal to 1 initially, and if x2 is less than x1, that is, see, if x1 and x0 and y0 are the first point and x2 and y2 are the second end point, if you are drawing a line from x1 to y2, x1 to y1 and x2 to y2, then this condition not necessary. But if we are drawing line from x2 y2 to x1 y1, then this condition is necessary. That is, if x2 is less than x1 and increment x is equal to minus 1 and initialize increment y is equal to 1. Similarly, if y2 is less than y1, increment y2 minus 1. Then x is equal to x1, y is equal to y1 is initializing. Now, if dx is greater than dy, that is delta x is greater than dy, that is we are drawing the line from x1 y1 to x1 y1 to x2 y2, then we have to draw this function we have draw pixel int x comma int y. So gl underscore point. This is nothing but rationalization. So when we give the endpoint, that is the x2 and y2, it has to be rationalized, then only it will be stored in the buffer. So rationalization is important. So to begin with the rationalization, we'll say gl begin and gl underscore points, and then we have gl vertex 2i, and then we have gl end, which is end the beginning. So next in the main we have draw pixel, that is x comma y. So e is equal to 2 into dy minus dx. This is nothing but as we have seen in the algorithm, that is p naught. P naught is equal to 2 into delta y minus delta x, that we have seen in the algorithm. So e will be equal to 2 into dy minus dx, with increment 1 is equal to 2 into dy minus dx, and increment 2 will be equal to 2 into dy, that is nothing but delta y. Then we have the for loop, that is I is equal to 0, I is less than or equal to dx, and increment I plus plus. If e is greater than or equal to 0, that is nothing but p naught is greater than or equal to 0, then y is equal to increment y and e is equal to increment 1. Else increment e and increment x, and draw pixel x comma y. So this is this if condition is for line, that should be drawn for x1 y1 to x2 y2. Now if it is in the bottom direction, that is from x2 y2 to x1 y1, then we'll be having this else part, that is draw pixel x comma y, e is equal to 2 into dx minus dy. As we can see before, it was 2 into dy minus dx, here it is dx minus dy. Then here it was dy minus dx, right? So then we have to increment 2 into dx. Then again we have for loop for I is equal to 0, I is less than dy. Previously we had for less than dx, here we have less than dy, and again I plus plus. And same condition, that is e greater than or equal to 0, do the same thing, that is x plus increment x, and e, which is nothing but p naught, will be increment of 1. Else we have increment in e is equal to increment 2 and y is increment y, and we have to again draw pixel x comma y. So then coming to the my display function, that is we have gl flush. that is, as we have used single buffer, we have to give GL flush. So remember, this GL flush is important because only then we'll be able to get the output. So coming back, we have my int and GL glut display function, and then we have glut main loop in the main program. So glut main loop is basically, see, in the routine, the routines that we have given in the program needs to be, they need to be according to the repetitive. They have to be done repetitive again and again. So this main loop has to be called again and again. So we can say this, we can call this as an event processor. So this glut main loop finally returns 0. So in the program, in the execution, we can see you can give any values. We will give 100, 100 for x1, y1, and x2, y2 we will give 400. So we can see in the output that we are getting a line. So this will be our Bresenham's line drawing. Bresenham's line drawing. Hope you have understood this. Hope it will help you to understand the Bresenham's line drawing using the endpoints. That's all for today's lecture. If you have any doubt, you can post your doubts in the comment section down below, or you can ask in the group. Okay, thank you.